Hey, so I'm going to talk about my OpenCV scene detector. It's written in Python and it uses Python's computer vision module, which is OpenCV. And computer vision is just basically taking images and videos and looking at them as arrays of numbers. Because a frame or an image is really just it's a collection of RGB values, which is how a computer looks at color and it looks at images. And you can do different manipulation. You can cluster pixels together and values together, and there's a lot of stuff you can do with it. So this program takes two frames, subtracts them from each other, and calculates the percentage difference between the frames. So the idea is that as a video is going, it's going to be doing sequences. So it's just motions which are similar frames. So it's like you see an animation or a motion, and each individual frame is similar comparatively because it's just part of a sequence. But when there's a scene change, the camera switches from the current sequence and flips to another one, so it's a big jump in percentage difference. So we're going to calculate that with OpenCV. To start this, we're going to import CV2, NumPy, and Matplotlib. And that CV2 is the computer vision module, and then NumPy and Matplotlib are for manipulating the arrays of RGB values and subtracting them, comparing them. And then Matplotlib also has functionality to put all this information into a graph. So we're gonna take the percentage differences and we're gonna plot them onto a graph at the end of the video. So we're gonna start a new video capture, which is just loading the video into OpenCV. I have a video called Gorillas. It's just an example nature video. It's in the same folder as this Jupyter notebook, so I don't have to specify the file path. I can just write the video because it's in the same folder, and Python assumes that we're looking for files in the same folder. So we're gonna start the video capture, and we're going to gather the parameters for the new video, because after we're done subtracting the two frames, we're gonna output the display, which is gonna be a black screen, and then all the pixels you see are the different frames. So it's like previous frame, there's slight motion. Okay, all the new pixels are gonna be displayed, unless it's a scene change. Then all the pixels will be shown. So we're gonna get the width, the height, and the frames per second. And OpenCV has these built-in functions to look at the video capture and get the size and get the frames per second. So it's like a video is just a sequence of still images, and the more high definition a video is, the more images there will be. So that's the frames per second. Every second is how many images you're being shown. So we're gonna get that, and then we're going to decide what our codec is for writing the new video. So when you're creating, you're changing the file format, or you're taking one video, making it into another video, all the visual information is loaded into the codec. So it's coded, the computer does it does calculations on it, and then it's decoded into the new format. So there are different codecs you can use. This is MP4V, which is good for MP4s. Other common ones are like H.264, I think it is. There's other ones. There's like XVDI, which is good for AVIs. But you can research whatever. Research if you want to create a different file format, like you want to make an MP4 an AVI or a movie or MOV. You can pick which codec is best for doing that. So we're going to use MP4V, and now we're going to calculate we're gonna iterate through the video and calculate the percent difference, and then take each frame and write it into the new video. So we're gonna do that with by opening up the two frames in OpenCV, subtracting them, and then getting the absolute difference of the two frames, and then taking that and putting that into a list. So we have that right here. We started our We've set up an I variable to count how many videos we're writing. So if we were outputting all the scenes in a video, like we were cutting up the video, we would want to iterate through and write a new video every time a scene is changed. So we're gonna do video writer. I just have it in F string, so every time a new video writer is created, it iterates and puts in the I variable. So it'll start off as 0 and it'll go 1, 2, 3, 4. And then here are all the parameters that we set. We're gonna loop through the first video, or we're gonna loop through the first frame in the video, and since it doesn't have anything to compare it to, the previous frame, the old frame, is gonna be set to none. So after we loop through the first frame is gonna become the old frame, and then it's gonna loop through to the second frame and then compare number 2 to number 1. So that's why it's set to none initially, because the first frame, there's nothing to compare it to. So it's gonna go through that, and as long as the video capture is opened, it's gonna run through, check to see whether the old frame is not none. So if there's another frame looped in, and it's gonna calculate the absolute difference between the current frame and the previous frame. And it's gonna output that as a NumPy type. This is just so that the computer can read it. And then it's going to get the percentage. So it's going to get the array, the NumPy array. It's going to multiply that by 100 and then divide it by the size. And then that's going to be the percent difference between the two frames. So it's going to print that, and then it's going to add that to our empty list of percentages that we defined up here. And we're going to loop through, and it's going to output the difference. So it's going to show the first frame and then subtract, and then it's going to be black where the pixels are the same, and the only thing you'll be seeing is a new pixel is where it's different. So I'm going to start it running now. Wait, let me start again, and now it's going to output the difference. So this is like a video of this nature woman, and she's interacting with these gorillas, and we're seeing that as she's swaying back and forth, we can see like the outline of her, and that's being displayed as the percent different in frame. And you can see as the camera is changing, there are these flashes. So that's when the percent change spikes, and that's when there's a scene change, because it's going from one sequence and it flashes and it changes to the next sequence. So that's what we're interested in. We want to capture where those flashes are, and then we know to go in and cut the video up or whatever. We can identify where the scene changes is because the percent difference is so high. So I'm not going to go through the whole video. It's like a 2-minute long video. I'm going to quit here. And you can see that we were outputting all the percent differences. So you can see that it's it goes. These are all relatively small percent difference, and then there are spikes. So it's like under 65% difference, and then there's a spike here where it's almost every single pixel is different. So that's probably a scene change. So we're interested in getting that, going through and getting that. But first, we want to take all these percent differences. We have them in a list now. We want to get the mean, and then we want to get the standard deviation of, okay, so what's the average? We have every single value. What's the average distance from the mean? So that we can then say, like, okay, like the average percent difference is 15%, whatever. So it's like everything that is more different than that, we're interested in keeping, or everything that's more than 2 standard deviations we're interested in keeping. We're going to decide what the threshold is, but we're going to calculate that with NumPy. So we're going to get the standard deviation. We're going to call NumPy standard deviation and calculate that, and we're going to calculate the mean, and then we're going to get the first z-score, which is the mean plus the standard deviation. So that's a z-score of 1, because it's 1 standard deviation from the mean. So I just decided that, okay, like I want to capture everything that's above 1 standard deviation, and we'll just see how that goes. So if we were going to go back in and chop this video up based on every okay, so we want to cut the video based on if there's a frame above standard deviation of 1, we're going to have to go back in and get all the z-scores. So we're going to have to see how far away each percent difference is from the mean. So we would have to run the loop one time, we would have to go through the whole video, and then we would have to go back in and get the z-scores. So that's what I'm doing here, and then see it outputs the difference and then the z-score. So we're not going to use that for now, but if we were going to chop it up based on percent or based on scene changes, we would need the z-score. So now I'm going to take all the information we got and I'm going to plot it on this graph. I'm gonna plot. I already plotted it, but I'm not going to show you that for right now. But I'm going to take all the percent differences, plot them on the graph and on a line plot, and I'm going to show where the mean is and then where the first standard deviation is. And then you're going to see that there are spikes where the scene changes are, and those are above 1 standard deviation. So I'm going to run that, and you can see here it's kind of small, but we're going to zoom in. And we only got about 30 seconds of this video, but you can see that here are the sequences, and then all of a sudden it jumps up above 100 or around 100%. Scene change, jumps down, sequence, jump, and we know that we can cut this up because it's probably a cut. Here's interesting. I might, to get rid of this, I might change the threshold a little bit. I might manipulate the threshold, or I could say that I want to cut the video up based on a frame that is above a z-score of 1, and set a counter where it can't be. It has to be a certain number of frames before it'll cut again. Just to eliminate this, because this is probably just a lot of motion going on in this sequence. So that's how I would deal with that. But yeah, so that's the project so far. We're identifying we're taking each frame, comparing them, getting the percent difference between the 2 frames, calculating the z-score based on all the data, finding how many standard deviations it is away from the mean, and then from there we know, okay, we can cut the video because we have scene changes, because it's going to spike up high when there's a scene change. And there are also we also know that sometimes there's a lot of motion in the shots and there's a lot of difference in the sequence, so we want to set some type of catch to get these high difference sequences. So I might say it has to be more than, every time there's a cut, a counter starts. It'll count frame 1, frame 2, frame 3, frame 4, and it's not going to make a new cut until it's above 10 frames, or however many. So yeah, so that's it. Thank you for watching.